Hello, my name is Timothy Tan, and today I will be going over my baseline model for my project, which is called Lung Infection Detection using Neural Networks. In this project, I perform image classification on chest X-ray images to identify whether the chest X-rays pertain to patients with COVID-19, pneumonia, or that have neither of these infections. The performance metrics I chose were based on classification problems, and these are accuracy, precision, recall, otherwise known as sensitivity, specificity, F1 score, and confusion matrices. I will pay particular attention to sensitivity and specificity because I came across an article stating that these metrics are particularly important in the medical device industry, and this neural network can be seen as a type of medical device. I obtained target values from the publication by which I found this project, and they reported accuracy, precision, recall, specificity, and an F1 score. And all their target values were around 90% or greater, so I hope to beat these reported values. So to get into the baseline model, the architecture I chose was a 50,176 by 100 by 3 fully connected feed-forward multi-layer perceptron. And in this model, I take a grayscale image of whatever dimension. I rescale it into 224 by 224 by 1 array. I then flatten this array into one dimension, and this 1D array composes my input layer with 50,176 inputs. The input layer is then fed into a single hidden layer with 100 neurons, and that uses the ReLU activation function. From the hidden layer, the information is then sent into the output layer with 3 outputs corresponding to whether the chest X-ray image pertains to someone with COVID-19 that has no infection or that has pneumonia, and this output layer employs the softmax activation function. So after training the model, I observed that the final training and validation accuracies were quite low. The training accuracy was 67.6%, and the validation accuracy was 66.7%. And on the right, you can see a plot that that shows how the training and validation accuracy change with the number of epochs. And the training accuracy, which is the blue line, is seen to steadily increase as the number of epochs increases. And from this plot and the final results, you can see that this is a case of underfitting, and to improve the performance, I plan on increasing model complexity as well as increasing the number of epochs. And I also looked at the confusion matrix, where I tested this model again on the training data, and you can see right below the confusion matrix, the accuracy is 42.6%, which is lower than the training accuracy we saw in the previous slide, indicating poor performance on the training data, which the model has already seen. In particular, on the top left corner, we see how the model performs on the COVID-19 data, and on the COVID-19 data, it has a precision of 9% and a recall of 5%, and these are particularly low. And to diagnose this problem, I plan on searching for more COVID-19 chest X-ray images, as well as performing data augmentation to improve the model's performance and in particular to improve the model's performance on COVID-19 X-ray images. Thank you.